All right, let's talk about something I'm sure you've noticed. You see a product label, right? It's got this big, impressive potency number, and then it just doesn't quite hit that way. Sound familiar? Well, you're not going crazy. Today, we're going to solve what I call the potency puzzle and figure out where all that missing potency actually goes.
So what's going on here? Why does some of that THC just seem to vanish when you heat it up? It all boils down to what happens when you apply that heat. But spoiler alert, that process is far from perfect. Is the good stuff being destroyed? Is it changing into something else? The answer is all in the chemistry of the plant. And trust me, it's a really cool journey from raw potential to the final effect.
And this right here is the heart of the whole puzzle. Those numbers on the lab report don't always match up with your real-world experience. To solve it, we've got to understand what those numbers are really telling us.
Now, this isn't about tricky labels or anything like that. It's about a fundamental chemical change that happens every single time. So let's start at the very beginning, with the key molecule at the heart of it all.
To really get this, we have to go right inside the raw cannabis plant. And that means we need to introduce the main character of our story today, a molecule called THCA. Okay, so what exactly is THCA? Well, think of it as the parent molecule. It's the raw, natural acid found in the cannabis plant before it becomes the delta-9 THC we're all familiar with. And the two most important things to remember here are raw and non-psychoactive. Yep, in this form, it's not going to give you those classic effects. It's pure, locked-up potential, just waiting for the right key. This little chart lays it out perfectly. THCA is that locked potential. The power is there, but it needs a key to turn into the unlocked, active delta-9 THC. And as you can see, that key is simply heat. It's this one transformation that makes all the difference.
So how do we get from that locked state to the unlocked one? Well, it's not magic. It's actually a very specific and pretty well understood chemical reaction.
The fancy scientific name for this whole unlocking process is decarboxylation. I know it sounds super complex, but all it really means is removing a specific part of the molecule, this thing called a carboxyl group, and you do it with heat. Every time you smoke or vape or even cook with cannabis, you're kicking off this exact reaction.
And look, this breaks it down so simply. You start with your THCA molecule. You add heat. A little piece of that molecule, basically carbon dioxide, snaps off and floats away. And what you're left with is the active delta-9 THC molecule. It's really that straightforward.
Okay, so that seems easy enough, right? One molecule turns into another. So why don't you get a perfect 100% conversion? Why isn't 100 milligrams of THCA equal to 100 milligrams of THC? This is the real mystery at the center of the puzzle.
And here is the aha moment. It all comes down to some super basic science. You know that little piece of the molecule that breaks off, that CO2 group? Well, it's not weightless. It actually has mass. So when it detaches and floats away, the molecule that's left behind, the delta-9 THC, is literally lighter than the THCA molecule we started with. It's a simple loss of weight. It's not magic, it's math.
And because scientists are awesome and know the exact molecular weight of everything involved, they can calculate the absolute maximum possible yield from this reaction. And that brings us to our magic number, 87.7%.
Let that sink in for a second. Even in a flawless lab setting, like in a perfect world with a perfect reaction, you can never get more than 87.7% of what you started with. So for every 100 milligrams of THCA you have, the absolute best you can possibly hope for is 87.7 milligrams of active delta-9 THC. Right off the bat, you've lost over 12% of the mass just due to chemistry.
But here's the thing, that 87.7%, that's the theoretical maximum. That's the science fair project version. As we all know, the real world is, well, it's a lot messier than a perfect lab. So let's see what happens when this reaction goes from the lab to, real life. Because in reality, all these other factors jump in. The heat from a lighter, for instance, is totally uneven. Some THCA might not get hot enough to convert at all. On the flip side, if it gets too hot, you can actually destroy the very delta-9 THC you just created. And of course, any smoke that just drifts off into the air is taking active compounds right along with it. All of these are extra losses on top of that initial chemical loss. This chart really puts it all into perspective, doesn't it? You start at the top, 100% potential all locked up in THCA. Then, bam! The unbreakable laws of chemistry knock it down to that absolute maximum of 87.7%. And then, real life happens.
All those messy, inefficient factors take an even bigger bite. What you're left with, what you actually experience, is way down here. Suddenly, the puzzle doesn't seem so puzzling anymore.
So now that we kind of get the problem, how do we use this information? What's the smart play here? Well, that brings us to what I'm calling the efficiency equation. How do you get more of what's promised on the label into your system?
This slide just nails it. It shows why not all products are going to behave the same way. Over on one side, you've got something high in THCA. Its potency is all potential, and it relies completely on that risky, inefficient conversion process we just talked about. But on the other side, you've got a product with more of its potency already in that active delta-9 form. It basically gets to skip a big part of that wasteful step. So what you see on the label is way closer to what you actually get.
And that's the big takeaway, right there. It's just more efficient to start with more active delta-9 THC. You're not losing as much in that chemical conversion process because, as the plant matured, it already did some of that work for you.
This quote from the source material just wraps it all up perfectly. A more mature plant basically gives you a head start. By having more active delta-9 from the get-go, you minimize the waste that's just baked into the conversion process. It's not just about the total number, it's about what form that number is in.
So, here's a question for you. The next time you see a lab report, are you just going to glance at that one big number? Or are you going to look a little closer? Because now you know the secret. You know to look for that ratio between THCA and delta-9 THC. You've cracked the code on the potency puzzle. Thanks for diving in with me on this one.